We're going to understand the electromagnetic spectrum, explain how light can be polarized, understand the difference between both, and we will use Malice's law to calculate polarization of light. So first thing is you have a few different types of electromagnetic radiation in a spectrum, starting from the left with the biggest wavelength, you have radio waves, then microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. We need to know them in order, okay? There's a little song up here that you can click the link on in the PowerPoint and you can actually listen to the song. I'll link it in the description below. So what happens is, wavelength is great on the radio waves side. So we have a big wavelength, which means you will notice that the frequency is less. There's like one wave here. We have a lot of waves here. Remember, frequency is a number of waves. So on the left-hand side, we have a small frequency. You may also remember that frequency and energy are directly proportional with each other. So if I have less frequency, I can carry less energy. As you move along, you will notice that the wavelength is starting to decrease on the right-hand side, but the frequency is starting to increase. If the frequency is increasing, that means of course my energy will also increase, which is what makes gamma rays quite dangerous. They carry a lot of energy. And you should know some uses of each of the types, which I've written here below for you. There is a formula to calculate the frequency or the wavelength, knowing that is electromagnetic radiation, which means they all travel at the same speed. This is C. It's supposed to be V. V equals F lambda from previous lessons, but we've changed it to C to let you know it is a constant, which is the speed of light, which is 3 times 10 to the power of 8 meters per second. That's 300 million meters per second. It's really fast. So you might get a question that asks for the wavelength of a light which has a frequency. You're expected to know that you would use the speed of light, so you'll do 3 times 10 to the power of 8 divided by the frequency, and then you'll get your answer. There's another example here. You have a different frequency. Same way, you do the speed of light divided by the frequency, and you have your wavelength. Next, we move on to polarizing the light. So you have a whole bunch of light coming in at all different angles, and that can cause a lot of glare and some unwanted light getting through, so we can block some of the light. That's the idea of polarization. Light is coming in at all angles. You have a polarizer which only allows certain light to come through, like a certain direction. So that's what would happen here. So if you were looking at a wave coming towards you, this is your eye, and you see the wave coming towards you, if it's polarized, it's only coming in one direction. Unpolarized can come in all different directions. So there are 4 ways to them. We have selective absorption, reflection, refraction and scattering. We don't really need to look at these in any detail at all. We have to focus on this one here. So this is what I'm going to focus on in today's video. Selective absorption is like when you use a filter to block some of the light. So if I only allow the up and down part, everything else would get blocked, the left and right. So I will actually lose half of the light. So it's a bit like a picket fence. It passes through the first one. If you put a second one at the same angle, it will pass through as well. However, if you pass through the first one, it will allow the straight light to come in. But if you horizontally place the next one, that will block that, because this is going up and down. And now that I've got this left to right, it will block it. I'll cover that in more detail later. In everyday situations, you will see that you can look at a puddle of water or some glass. You can see the reflections and the glare, but if you put a polarizing filter over your camera, you can actually see clearly underneath, clearly behind. There is no glare coming. That's what your shades do. Sunglasses. Sometimes you might have a little P written at the side, which tells you it's polarized. It blocks out unwanted glare, so it's easier for you to see what's going on. So now, if you wanted to if you wanted to calculate the intensity of the light, we will use Malice's law, which is this one over here. I, which is the intensity we're looking for, is equal to the starting intensity multiplied by cos of the angle squared. You normally have a polarizer and then an analyzer like this. You will have 2. Light will come in, and then it will pass through to the next one as well. Usually, because this is facing in a certain direction, we could just say facing upwards, it will always become half. So if I had intensity coming in here, whatever is over on this side will just be a half of the I. That means on this side, you still have this half I, and then you may have like an angle. This may be 20 degrees, 30 degrees, and then we're going to go ahead and calculate it. So, this is a quick summary. The 4 types, we're focusing on the first one. We will use Malice's law in a couple of practice questions now. Here we have unpolarized light with an intensity of 100 watts per meter squared, passing through 2 filters, 40 degrees angle from each other. What is the intensity of the light coming from each filter? So as you may know, from the first filter, as it passes through over here, we have 100 coming in. As I mentioned, this is going to block half of the light, so coming out of the first filter, we can easily say this will be 50 watts per meter squared, so it's the first one. To the second one, we have 50 coming in, but we have a 40 degree angle now, so now I need to figure out what the new one would be. So what I can do now is I can do I equals the I coming in cos of the angle squared. It's written here in the formula, but you can write it at the end. The calculator will get the same answer. So what I'm going to do is to find my I. I will not use 100 because I've already passed through it and I've cut off half of it. So I will have to use 50 because that's what's passing through here. So I'll do 50. 50 cos, that's a C by the way, cos squared, and the angle is 40 degrees. Make sure your calculator is in degrees. 50 times cos 40 squared, you should get 29.3. So I'll just call it 29 watts per meter squared. Very nice. Here's another one here, another type of question that can come. You have starting intensity of 72, passes through 2 filters. At the end, you have the final intensity. What is the angle between the 2 filters? 72 coming in, which means after the 72 coming in, it is obviously halved, so that becomes 36 over here. So passing through here, we have 36 watts per meter squared going in, and the final answer is 9. We need to solve for the angle. So we can do that. So we're going to set up the formula from here because 36 is coming in. So I equals I naught cos of the angle squared. No problem. I have my I, the emerging one, which is 9, equals the current, not the current, the light coming in, which is 36 cos squared of the angle. So now I need to rearrange just to get the angle. So I will do 9, I'll divide both sides by 36, so 9 over 36, that will cancel that out. That will give me my cos squared of the angle. I will now remove the square by taking the square root of both sides. So I will do the square root of whatever I have here, which is 9 over 36. And that will give me cos of the angle. That's nice. To isolate the angle, I must do cos inverse. So I'll write cos minus 1 and square root of 9 over 36. Now plugging that into my calculator, I should get the answer. So I will do shift cos. I'll do the square root of my fraction, which is 9 over 36. And I will get an answer of 60 degrees. Another example, polarized light passes through a filter at this angle. What is the intensity of the emerging light in terms of I0? I've actually written this one out. So you can actually have it as I equals I naught cos squared of the angle, as you already know. We know the angle is 30 degrees, so I is I naught cos squared 30. So all you do is in your calculator, cos squared 30, you should get 3/4. So whatever the intensity of the light would have been, it is going to be 3/4 of it. There were no numbers given, we're just doing it in terms of I. So I will just take this part and calculate that to get 3/4. So 3/4 of whatever I naught would have been. A final example is like this. An unpolarized light with I naught passes through 2 filters at 90 degrees with each other. What is the intensity of the light that's going to come out now? Interesting. So the first one is going to be like this. Let's say it is straight. Okay, so you will get half. But the second one is at 90 degrees. So you will know that this is only blocking half of the light, so you have the up and down light coming in. And because this is horizontal, this will completely block it. You should actually get 0 coming out. How will you know this? Well, if you do cos of 90, or even if you do cos squared of 90, it doesn't matter, that gives you 0. So you do not need to do any calculation at all. The answer will simply be 0. Thank you.